So when we left off, we were talking about effective rate, and I had a problem for you to work on. So let's take a peek at it. Find the effective rate for an investment at 9% compounded monthly. And several of you brought up, I didn't give you a dollar amount. Well, it doesn't matter. No matter what the dollar amount is, the effective rate is going to be the same. So I'm just going to pick one. I always pick like $1,000 or $10,000 just because that makes life so much easier. So I'm going to use $10,000 as my present value. So step one is still future value after 1 year. The assumption that's being made here, of course, is that this investment is at least 1 year long. So our future value, I'm going to use my $1,000 times 1 plus 0.09 divided by 12 to the power of 12, because we're going for 1 year. Giving us $1,093.81. So this is the reason why I use 1,000, because now it's really easy to find the amount of interest. We're going to subtract $1,000. So we get the interest is $93.81. What's next? Perfect. Using the simple interest formula, the interest, $93.81, equals our principal of 1,000, times our rate, times our time is 1 year. So we're going to solve by dividing by 1,000, which is going to give us 0.09381 equals our rate. Then we move the decimal point over 2 spots to get 9.381%. And if we're sticking with rounding to the nearest hundredth percent, we've got tenths, hundredths, that rounds to 9.38%. What do you think? You use 2,500 for yours? Oh, because then you'd have to make sure you put 2,500 in here instead of 1,000. Did you? What did you have for your interest? No, for your dollar amount of interest. Something was off there. I'll run the numbers for you. So let's find our future value. It would be 2,500 times 1 plus 0.09 divided by 12 to the power of 12. Okay, there you go. Okay, that does it. Because you should end up with something like $225 in interest, somewhere in there. Any other questions? Do you want me to work through that one, Brooke? I can figure it out. You got her? Okay. Okay. Now I promised you I'd show you an example of less than a year. So let's find the effective rate for $4,000 invested at 7% compounded monthly for 8 months. So now our first step changes slightly. Because the period of this is less than 1 year, we use the actual period. So our future value is going to be the 4,000 times 1 plus 0.07 compounded monthly, so it'll be divided by 12. But instead of to the power of 12, it's going to be to the power of 8. Because there's only 8 months, which means there's only 8 periods if 1 month is a period. So 4,000 times 1 plus 0.07 divided by 12, the power of 8, giving us 4190.52. So then we find the amount of interest. So 4190.52 minus our $4,000 principal gives us $190.52 in interest. Step 3 is also slightly different then. Using our simple interest formula to find the rate, well, their interest is $190.52. The principal is still $4,000. And we're still looking for the rate, but our time is no longer 1, it is 8/12 because it was 8 months. So, to solve this, I'm going to do this. I'm going to divide by 4,000 times 8/12. The reason I'm going to do that instead of dividing it out is because it would give us an ugly decimal, and I don't want to round it off and punch it back in. So what I'm going to do on my calculator is this. 190.52 divided by, I'm going to use my parentheses now, 4,000 times 8/12, so it's going to be times 8 divided by 12. And close the parentheses. Equals 0.071445 equals my rate. What's next? Make it a percent, so we move it over. 7.1445%. Now I didn't give you rounding again, so we're going to assume it's the nearest hundredth of a percent. So yes, 1, 2, we rounded off there, 7.14%. Questions?
I think I got a different answer, but I think to get around it, I actually did the 4,000 times the 8 over.
So you got like 7.13.
Yeah.
And that's why I caution you not to write down numbers and punch them back in, and whenever you can avoid it, keep it in your calculator as much as you can. Otherwise, that round off will throw you off.
Everything.
Yeah. Okay. Well, the other side of this is, what if we know we want a certain amount of money in the future? Let's say we want $5,000 in 4 years to buy a new car. What we're looking at here, before we had this present value. I'm just going to label it PV for now. And we were using that present value along with our interest rate and our compounding, and then of course our period or our length of time to find the future value. But in this case, the 5,000 is not money we have now. It's how much we want to have in the future. So in this case, the 5,000 is the future value. And we want to work backwards to get to the present value. This happens a lot when we're dealing with these type of calculations. The annuity calculations we're going to start next week, we're going to do this a lot. Where this is important, where this, what happens with this is we just take our formula. Remember, we have our formula for future value is equal to the present value times 1 plus the rate divided by the number of periods in a year to the power of the total number of periods in the investment, n times t. If I wanted to solve this for the present value, what would I do? Yeah, it's multiplied by this whole works right here, right? So to get rid of that, I would divide. So I end up getting the present value is equal to the future value divided by 1 plus r divided by n to the power of nt. So for our example here, we wanted $5,000 in 4 years. Now this might be, why would you ever want this? It might be that you have a business and you have excess profits available right now and you want to invest them so that in 4 years you can replace a work vehicle or a piece of equipment or something like that. Whatever. Or you may have got an inheritance, but right now you're not going to use that. Maybe you want that money available for college in so many years, or you want to buy a house in so many years. You want to know how much to save and put away and how much you can play with, how much you can blow on yourself. So here you want $5,000 in 4 years, and you know that you can receive 4% compounded quarterly. So the setup's going to be the same, only now we're looking for present value instead of future value. $5,000, but instead of times, it's going to be divided by. Everything else is the same. 1 plus 0.04 for 4%, divided by 4, because it is quarterly, to the power of 16. 4 years quarterly, so 4 times 4 is 16 periods. So it would be 5,000. Now, before I get an answer, do you expect this to be bigger or smaller than 5,000? It better be smaller. We are investing to get to a result of 5,000, which means we probably should be able to start with less than 5,000. And we get 4,740 and 74 cents. So 474.074. Did I punch something in wrong?
12.
I did divide by 12 instead of 4. Thank you. So 5,000 divided by, parentheses, 1 plus 0.04 divided by 4 to the power of 16. So yes, 4264.11. So you're getting, $740, $736 in interest on that money. What do you think? Not horrible? Better than a sharp stick in the eye?
Would that 4% come from the bank?
Yeah, that's if you're investing it in the bank or something else. That's money that the bank is giving you, or whatever, wherever you're investing is giving you an interest.
Is there more aggressive interest moving?
Well, you can get into like bonds and stuff like that where you might get 7 or 8%, but then there's some risk that could actually lose money, a little bit of risk.
Yeah. So if you go more aggressive, there's a chance of losing.
Yeah.
It's a gamble.
It's a gamble, yes. Right now, any guaranteed money you're going to be making like less than 2.5% on it. But I think you always, yeah, that's guaranteed on like CDs and stuff like that. What you look at is your loan rates. If your loan rates, like right now you can get a car loan for 1.99% if you have good enough credit. So they're not going to pay anybody more than 2% interest because that's all they're getting for interest when they loan that money out. There's usually a 1%, a 0.5 to 1% difference between their loan rate and what they're paying for interest. Also, you look at inflation. Back in the late 70s, you could get I actually have the passbooks for CDs I had when I was like 4 years old that I was getting 16% interest on. But inflation was at about 14% at that time. Okay. I mentioned other forms of compounding. We've looked at quarterly, we've looked at monthly. I want to look at annually just briefly, just because I want to show you this. I think I mentioned it a little bit before, but how many of you are below the age of 30? Below the age of 25? A few of you? We've got an old class this time around. Let's just put you at 25. No insult for those of you that are over that, because I am well over that myself. And let's say you're going to work till you're 65. Think you'll make it? No?
No.
So anyway, that's a bad road to go down. We're going to stay away from it. You plan on living 40 years. If you can invest money for 40 years, even if you look in the stock market, every 40-year period in the stock market over the last 130 years of its existence, even in 40-year periods that include the Great Depression in the 20s and early 30s, the average return has been about 13.5% per year. So if you're investing money and you can leave it there for 40 years, now I don't think it's going to come back nearly as strong as it used to be, so I think it's going to be a little less than that, but you could probably still come out with an average of around 10 or 11%. So let's say you can make 10% annual on that money if you go to an investment planner and let them invest it for you.
Does that include their fees?
That's their fees and everything coming out of it, yes. Which is a good thing to bring up. If you're going to go to an investment planner, that's one of the things you always ask is how do they get paid and how much, and compare from one to another. They do have some.
I have one that's called a Century Savings.
Yeah, like a money market type account, yeah.
Does it matter like how much money you have, the interest goes up?
Yes, generally if you have over 2,500, you get a little more interest. Over 10,000, there's a little bit more. And if you lock it in for a longer period of time, there's more. So if you can get that 10%. Now let's say you get done school, you're about 25 years old. And again, for those of you that are older, don't be depressed. I'll go over some numbers for that in a minute. And let's say you get out of school and you live cheaply like you did as a student, and let's say you can put away $3,000 in a year in savings. Put it in a retirement fund. The future value of that $3,000, and we're going to say this is compounded annually because we're not going to go into annually, of course, means just once a year. So this is going to be 1 plus 10 divided by what? 1. Yeah, in fact, it should be 0.10 for 10%. 0.10 divided by 1 because it's only compounding once a year to the power of, careful, 40 years. Once a year would be 40. So this would be 3,000 times 1 plus 0.1 divided by 1, which I really don't need to divide by 1. I'm just doing it for show. The power of 40. $135,778, basically. So if you can put that money away when you're 25, at 65, that's how much you'll have. For those of you that are a little bit older, let's do the same calculation. For if you're 30. So if you're 30 and you do this, you only get 35 years. You're only going to get $84,307. Yeah, that 5 years comes close to cutting it in half. Let's say you get a little bit older and you're 35 before you do this. So this is at 30. This is at 25. So you hit 35. Now it's only going to sit there for 30 years. You would only get $52,348. You're looking now at about 1/3 of the person who did it at 25.
That's
you just double money.
Let's say you wait till you're my age. I'm 40. Well, I'm 41, but we're going to call me 40 for today. Oops. I almost cheated and put an extra 1,000 in there. And of course, I'm only going to get 25 years in that investment. I'd get $32,504. So I literally am going to get like 1/5 of what the person who did it at 25.
Do you have to file like insurance on that?
You don't have to, no. But there is some risk involved with it. I've had years where I lost 30%. I've had years where I gained like almost 60%. Yeah. I mean, if it's money you can afford to let sit there for a long time, it's okay. If you're getting to within 5 or 6 years from retirement, you might want to pull it out and put it in something safer. And again, that's something to discuss with an investment counselor other than me. Somebody asked, what if you were 20? Well, now you can let it sit there for 45 years. You'd have $218,671. So that extra 5 years at the beginning comes close to doubling it. Now you think about that, that's just $3,000 a year. If you put away, $5,000 a year, it would be almost double that. Or $6,000 a year, it would be exactly double that.
That's if you put 3,000 in a year.
No, that's $3,000 that one time.
So if
One
you have,
time?
That's one time. Okay, well, rather than doing the annuity formula, which we will look at next week, I'm going to cheat and do this. So let's say we're going to start out with age 20 here, just to... We can adjust that in a minute if we want to. And we'll go up to 65. And I'm going to change this to 5,000 because 5,000 is the maximum you're allowed to put away each year into an IRA. Federal limits, $5,000. Unless you're over 55, then you can put away more. But we're just going to say you put away $5,000 a year in an IRA. Anybody want to guess?
7 million.
And that's 5,000 per year.
That's $5,000 per year. So almost $4 million. So let's say you decide, I don't want to start that out right away. Let's wait a while. And you don't start till you're like 27. Anybody want to guess?
1.5.
Just right around 2. It cuts it in half. This is one of the most significant little numbers I'll ever show you. Oops. Let's go back to this one. But now this one here, we didn't put anything away until we were 27. This one here, let's say that we put away for those first 6 or 7 years. And at 27, we decided we were done. We wanted to play with our money for the rest of our lives. Who do you think is ahead? Really close. Basically, you got the same balance there. These first 7 years were worth more than the next 38 years.
Why?
Compound interest. The money that you put in at 20 is sitting there for 45 years. The money you put in at 30 is only sitting in there for 35 years. 10 years less interest. It is.
You say I'm screwed then.
So how old are you?
I'll be 28 years.
You're going to be 28. So let's say you want to start at 28. You could end up doing pretty well if you put away $5,000 a year.
I know. That's like how much more money to put in? 5,000.
Let's do this for you. What's that?
Put 5,000 times 27 years.
But here, I'm still going to do this for you. Let's say that you start at 28 and you go to your 35. Or the other side of that is, let's say you say, screw it, I'm going to play for a while and I'm not going to start till I'm 35. You're still way better off to start now. The next 7 or 8 years of your life are worth more than the rest of your life combined, no matter what age you are. Obviously, you're better off if you're 20 and you're investing for the next 7 or 8 years, but
Yeah.
even at 27 or 28, those next 7 or 8 years are worth more than the rest of your life.
So if you're, yeah.
What's that?
But you can't put more in the top three.
Well, you can just only put $5,000 into an IRA.
Oh,
You can put up to 25% of your income in if you use like tax sheltered annuities, which those have to come directly out of your paycheck every week or every month at least. You can put up to like $15,000 or so. It's like 25% of your gross pay for the year.
You can't just put it all in at one time.
You can for an IRA, up to $5,000 can be one lump sum at any point during the year. In fact, you can put it up until you file your taxes the next year. You can put it away for that previous year.
What if we just put 5,000 in?
Once
You want to say 30 or 28?
at 28.
Is a financial advisor the same thing as an investment account?
Yeah, kind of like an Edward Jones or Fidelity or Legends Group. That 5,000 is 170 grand in your retirement. It's not a bad
I guess
deal.
it's not bad for a one-time investment.
Start at 20. The 5,000 just going to 20.
I mean, if you do it a couple of times,
Holy
double it,
that's so stupid.
So your next couple of years, Casey, you know what you got to do.
Yeah. You need to make some money for
May
that.
not eat for a couple months.
Yeah.
You know that money.
Those kids don't have to eat every
You
day.
don't have to eat.
They should take turns. They got to learn how to take turns like everybody else does.
Roadkill's fun and
Yeah.
everything.
They gotta learn.
Rice and beans are
Now
cheap.
we're retired and I see.
Get the 50-pound bag of rice, the 50-pound bag of beans. City water is cheap. They don't need milk.
No.
They get that at school.
At the time,
Yeah.
That's a food.
The biggest thing I use this for, and I know I used to do it myself, if you smoke, we got a couple in here. 5 packs a week sound reasonable? No? More? 1 pack a week? Oh, you're a lightweight. You don't count.
I used to smoke.
5 or 7 packs a week?
I used to do 7 packs a week.
So if you're looking at $50 a week times 50 weeks a year, and let's say you started at 20, and I realize the price has gone up, but let's just say that $2,500, and if you smoke till you're 65. Well, that's the nice thing. If you smoke, you probably won't make it to 65, so you don't have to worry about it. But just the amount that you spent on cigarettes is $2 million in your retirement fund.
I better stop smoking right now. I'll be happy for it.
I'll be a broke one, but I'll be happy.
Now that I've got everybody thoroughly depressed, let's do something else. That's my job as the math teacher, if you walk out of here feeling good about yourself. Okay, so that's something I have to put up there for my own conscience. I put it up there every year just for those of you that are younger. I know you're not thinking about retirement, but maybe you should.
What if we are?
What if you are thinking about retirement?
Edward Jones tomorrow.
I would call somebody in the next. I would work on it. I mean, even if you can only squeeze out a few $100, get started young is better than waiting till you're my age. The hard part isn't necessarily putting the money away. The hard part is leaving it alone, because there's always things. I had it put away when I was 18. Was doing pretty well at like 23 or 24. Had quite a bit in there, and then I decided I wanted to build a house.
Oh, yeah. You just put it in there the one time then?
Okay. So enough on the investment and the retirement. Let's look at their other forms of compounding. Let's look at daily compounding. Now we can use the compound interest formula for daily compounding if we wanted to. 1 year would just be 365 periods, 365 days. And our rate would be divided by 365 in our formula. But that gets to be some really nasty numbers. So in your book, on page 472, there is a compound interest. Actually, sorry, not page 472. It was page 466. Sorry about that. And this is daily compound interest. But you'll notice if you look at the top of the chart, this is not compound interest on $1 or future value of $1 like the last one was. This is compound interest on $100. So that means we have to adjust two things. One, the previous one, the future value table gave us the future value, the interest plus the principal. This one gives us only the interest. So that's big. Second is, it's per $100. So we have to divide our dollar amount by 100 before we use the table on it. So let's say that we have, well, let's just stick to an easy number, $5,000 invested at 3%, compounded daily for 2 years. 2 years is how many days? 730 days. If you look at our chart, there is a 730 days. It jumps from 365 to 730. So on the top, we have to find 3% in 730 days. What factor does it give there? Oh, the 3% isn't on there. Well, that sucks. Okay, well then we're going to bump that up then to 5%. 5% is over on the next page there on page 467. Go down to 730 days. We get what? Perfect. 10.516335 is our factor. What are we going to multiply by that? Not the 5,000. We take 5,000 divided by 100 first, because this is per $100. So it's $50, and it's 50 that we're going to multiply by this factor. So 50 times 10.516335, 525.82. That's $525.82 in interest. That's what we gained in those 2 years. So the future value is the original $5,000 plus the interest of $525.82. So the future value is $5,525.82. So as you can see, this table is even more inconvenient than the other ones. I don't know why they set up the table this way. Well, I do know why, because it's more accurate to have fewer decimal places, but still, it's silly. They could have just moved the decimal point over 2 spots and had it feature interest on $1. But oh well, someday when I rule the world. So anyway, let's say you invest. I'm going to have you guys do this on your own. Invest $2,000 at 1 3/4% for 90 days. Find the future value, your balance at the end of the 90 days. So you get a factor of 0.432429, $8.65 in interest. 2,000 divided by 100 is 20, so 20 times that factor is $8.65. So a future value of $2,008.65 in just 3 months, yes. Hardly worth it to go to work if you can make $8.65 in 3 months, huh? What's that?
Oh, I got it.
You got her? You must have grabbed the factory right above it. Yes, it looks like you did.
Wait, why is it
I know,
120 days
it's
when
like,
it says 90?
I use 90. So it'd be point.
Oh, yeah, I did.
Yeah. Okay. Yeah, it's not the one that's highlighted. It's the one right below the one highlighted. Okay. Now, we said there's something called continuous compounding. We're not going to get into that in this class. It involves using exponentials and logarithms. And I don't hate you guys that much, so we won't do that in here. But I do want to take a look at, this one is on page 472, and is the present value of $1. You know, we did that calculation a little while ago where we divided instead of multiplied. This chart, this is the way my math lab will do it. Again, I prefer you use the formula, but let's do one example of using this chart and one example of using the formula and see that they are a few cents different. Let's say that we're going to, or we want $30,000 in 10 years to build a house, or for a down payment. Let's say we figure we can invest, since it's 10 years, we can invest at 6%, and we're going to get that compounded. Let's make sure I get one that's on here. Compounded quarterly. Actually, compounded quarterly won't work. So it looks like I'm going to have to go compounded semi-annually. So if I'm using the formula here, all I have to do is this. The present value is equal to that future value of $30,000. What comes next? Divided by, because we're going the other way. Parentheses, 1 plus 0.06 divided by semi-annually means twice a year to the power of, 10 years times twice a year is 20 periods. Does everybody see where the 20 comes from? Any questions? And this is divided because we have the future value is the 30,000. That's how much we want to have at the end. We need to know how much we need at the beginning to get there. So 30,000 divided by 1 plus 0.06 divided by 2 to the power of 20. 16, 6, 10, 27. So that's how much we would need to start with. Well, let's see what the chart tells us. On the chart, we need two things. Rate per period, which is going to be how much? 6% divided by 2, because there's 2 periods in a year. So 3% is our rate per period. Number of periods. 10 years times semi-annually is going to be 20 periods. So on our chart, we've got 20 over here, 3% up here. We get a factor of 55368. What do you think we're going to do with that? Oh, we're going to figure 30,000 times that factor. $16, 6, 10, 40. You can see there's about 13-cent difference there. So in my math lab, if you're using the formula and you come off, that 5, 10, even 15 cents difference, it's probably just because you're using the formula instead of the chart. Don't worry about it. Write down the problem numbers. Send me an email saying, hey, on quiz 8 or whatever quiz it is, problems 2, 7, 6, and whatever, I marked it wrong, but I used the formula, and I'll go back and I'll change your grade for you. On the homework, don't worry about it. You know that it was just the formula versus the table. On the quizzes are the only thing you have to really inform me about. So for next week, there's actually a new quiz due tomorrow. That's Wednesday. That's on last week's stuff. That's on the simple interest and simple discount notes, U.S. rule, and all that good stuff. That's what's why, because it's on the last week's homework. The new homework will be on the new stuff. Simple discount notes. Yep. Oh, okay. Then of course there's a new homework due next Tuesday. We have 2 or 3 more lectures left. We actually have, after tonight, we actually have 5 classes left because of the weird semester. We actually get 17 classes in here.